Hello, welcome to the Calculus 2 of summer 2020. And in this course, you have to learn chapter 6, 7, 8, 10, and 11 within 8 weeks. And first test is based on chapter 6. The first part of chapter 6 is a review from the pre-calculus. So I understand that, or I believe that you guys know it, but still we are going to have a very quick review of that pre-calculus stuff. And I am going to share my screen so that explanation becomes easy. Just give me a minute. Yes, functions and one-to-one functions. A relation in two variables x and y is a function if one value of x leads to exactly one value of y. For example, you consider the equation x plus y squared is equal to 10. This is not a function because when x is equal to 1, you replace x by a 1. It becomes 1 plus y squared is equal to 10. Subtract 1 on each side. You get y squared is equal to 9. That implies y is equal to 3 or negative 3. Because 3 square is 9, negative 3 the whole square also is 9. That means one value of x leads to two values of y. Therefore, the relation is not a function. The graph of a function y is equal to fx must pass the vertical line test. And I have drawn three graphs here. Graph number 1, graph 2, and graph 3. Graph 1 does not pass the vertical line test. Graph 2 and 3 passes the vertical line test. So graph 2 represents a function, graph 3 represents a function. And now we are coming to the one-to-one function. Let y is equal to fx be a function. We know that one value of x leads to exactly one value of y, and the graph passes the vertical line test. In addition to this, if one value of y leads to exactly one value of x, then the function is called a one-to-one function. The graph of a one-to-one function must pass both vertical line test and the horizontal line test. Graph number 3 given above is the graph of a one-to-one function. So this one is the one-to-one function because it passes the vertical line test and also the horizontal line test. If you draw a horizontal line, that line crosses the graph only once. Whereas in number 2, if you draw a horizontal line, that line may cross the graph in two different places like this. So this is not one-to-one. The number 3 is one-to-one. And now you consider the graph of y is equal to x squared. This is not one-to-one because f of 2 is 2 squared, that is 4. And f of negative 2 is again negative 2 the whole square, that is 4. That is one value of y, that is when y is equal to 4. You get two values for x. So one value of y leads to two values of x. Therefore, fx is not a one-to-one function. And the graph number 2 is the graph of y is equal to x squared, and that does not pass the horizontal line test. Okay, now we are moving to composition of functions. If fx and gx are two functions, then f of gx. Remember, you write fx and take away x from fx and write gx there. We call it f of gx, or in short, f4gx. So to find f4gx, you have to replace x in fx by gx. Similarly, to find g of fx, you have to replace x in gx by fx. So one example is given here, that fx is equal to x squared plus 1 and gx is equal to square root of x minus 1. Then for gx, you replace x in fx by gx. So this x becomes square root of x minus 1 whole square plus 1. Square root of x minus 1 the whole square is x minus 1. So it becomes x minus 1 plus 1. 1 cancels, the answer is x. Similarly, g of x is equal to, you replace x from gx, that is, take away x and write x squared plus 1 there. X squared plus 1 minus 1 is square root of x squared is equal to x. Is it always true? No. Square root of x square is x only when x is non-negative, x is greater than or equal to 0. So we assume that x is greater than or equal to 0. So square root of x square is x. Now we are going to define the inverse of a function. Fx and gx are said to be inverses to each other if f of gx is equal to g of fx is equal to x. Inverse of fx is denoted by f to the power of negative 1 x. So remember, this is not the exponent, even though it looks like the exponent negative 1. It's not like 2 to the power of negative 1. We all know 2 to the power of negative 1 is 1 over 2. This is a different case. So this is just a representation of the inverse function. So don't read it as f to the negative 1. You read it as f inverse x. F inverse x exists only if the function fx is a one-to-one function. That is an essential requirement. If fx is not one-to-one, inverse does not exist. Okay, domain of fx is the same as the range of f inverse x, and the range of fx is the same as the domain of f inverse x. The graphs of the two functions y is equal to fx and y is equal to f inverse x are symmetric with respect to the line y is equal to x. Now, to find the f inverse, here is a small procedure. The procedure is here. Set y is equal to fx. Together with that, I have created an example here. And example is fx is equal to 2x minus 3. Find f inverse x. First step, set y is equal to fx. So y is equal to 2x minus 3. Next step, interchange x and y. When you interchange x and y, x becomes y and y becomes x. So that becomes x is equal to 2y minus 3. And you add 3 on both sides. It becomes 2y is equal to x plus 3. Now divide both sides by 2. You get y is equal to x plus 3 divided by 2. And final step is replace y by f inverse x. So f inverse x is x plus 3 all divided by 2. So keep in mind, to find f inverse x, there are 4 steps. First step, set y is equal to fx. Second step, interchange x and y, switch x and y, solve for y. Then finally replace y by f inverse x. And now there comes a theorem. That is, so far there were no calculus. Now calculus is coming to the picture. Theorem. Derivative of f inverse is 1 over the rest 1 over, that means the reciprocal of f prime replaced by f inverse a. So this is a procedure. First you find f prime x, then find f inverse a, replace x in f prime x by f inverse a, and then find the reciprocal. So it's a procedure. There are 4 steps. First find f prime x, then find f inverse a, then replace x in f prime x by f inverse a, and then find the reciprocal. And the proof is given here. Proof: let f inverse x is equal to u. Therefore, f of f inverse x is x. That is the definition of inverse function. That is f of u is equal to x. Now you differentiate with respect to x. You get f prime u times du over dx. That is the chain rule. That's the left side. First you differentiate with respect to u, and then differentiate u with respect to x. Multiply these two. That's the chain rule. The right side derivative of x is 1. That is du over dx is 1 over f prime u, and f u is f prime x. So f inverse prime x is equal to 1 over f prime f inverse x, and that replace x by a, you get that result. Okay. Yeah, now we are going to discuss the problems. Start with the question number 18. And the question is, fx is x to the 5 plus x cubed plus x. And you are asked to find f inverse 3 and f of f inverse 2. That question is copied from the textbook. A part. You consider this. When x is 1, fx becomes 1 to the 5 plus 1 to the 3 plus 1. That is, f1 is equal to 1 plus 1 plus 1, 3. f1 is equal to 3 means f inverse 3 is equal to 1. So f1 is equal to 3. So f inverse 3 is equal to 1. So that is answer to the first part of the question. Second part, f of f inverse 2 is 2. That's the definition. There is nothing to prove there. F of f inverse x is x. So f of f inverse 2 is 2. Okay, so that's it. Now, question number 24. That again is a pre-calculus question. Find f inverse x. Fx is equal to 4x minus 1 divided by 2x plus 3. So set y is equal to fx. Y is equal to 4x minus 1 divided by 2x plus 1. Second step, interchange x and y. Interchanging x and y, we get x is equal to, y becomes x. X is equal to 4y minus 1 divided by 2x plus 3. And x is equal to 4y minus 1 divided by 2y plus 3. Multiply both sides by 2y plus 3. You get x times 2y plus 3 is equal to 4y minus 1. Distribute x, 2xy plus 3x is equal to 4y minus 1. And that implies 2xy minus 4y. That is, you are subtracting a 4y and subtract a 3x on both sides. So 2xy minus 4y is equal to minus 3x minus 1. I did not show that subtraction here, assuming that you guys know it. Now factor out y from the left side. Y times 2x minus 4 is equal to negative 3x minus 1. Divide both sides by 2x minus 4. So y is equal to negative 3x minus 1 all divided by 2x minus 4, and that is f inverse x. So f inverse x is equal to minus 3x minus 1 all divided by 2x minus 4. Question number 26. Here the question is y is equal to x squared minus x. X is greater than or equal to 1 half. The reason here a restriction is imposed upon x is otherwise this is not a one-to-one function. You know y is equal to x squared minus x. You can very easily verify that. See, on the calculator you graph it. Y is equal to x square minus x square minus x, and then graph it. You see the graph does not pass the horizontal line test. So it is not a one-to-one function. But if you impose this restriction, that is, you impose the restriction, this must be in parentheses now, this time x square minus y is equal to, take away this, you start with a parenthesis, x square minus x, close the parenthesis, open another one, x greater than or equal to is in second math. Second math, you have greater than or equal to is number 4, 1 half. Close the parenthesis and now graph. See, that graph is a one-to-one graph because it passes the horizontal line test. So it passes the horizontal line test. That is the reason why that condition is imposed there. So from the graph, it is clear that it is a one-to-one function, and so the inverse exists. Now we are going to find the inverse. So set y is equal to x square minus x, interchange x and y, we get x is equal to y square minus y. Y is greater than or equal to 1 half because new y is the same as the old x. And that is y minus 1 half greater than or equal to 0. You complete the square here. In order to complete the square, you have to add the square of 1 half of the coefficient of y. So 1 half square is 1/4. So y square minus y plus 1/4 is equal to x plus 1/4. Factor the left side. Y minus 1 half the whole square is equal to 4x plus 1 whole divided by 4. So y minus 1 half is square root of 4x plus 1 whole divided by 4. That is y minus, you can discard the negative sign because when you find the square there are plus and minus, but this time you discard the negative sign because y minus 1 half is always positive in this case. So y minus 1 half is square root of 4x plus 1 or divided by 2 because square root of 4 is 2. And now you add it 1 half to both sides. Y is equal to 1 half plus square root of 4x plus 1 whole divided by 2, and that is f inverse x is equal to 1 plus square root of 4x plus 1 whole divided by 2. So that is how you find the inverse of a function. Second page, now you have to note because these problems are not really easy. They are of the first kind of problem that you are going to come across. So pay attention. I have written two notes here. To find f inverse A, there are several ways to find f inverse A. Set fx is equal to A and solve for x. That is one way to find f inverse A. To find f inverse A, set fx is equal to A and then solve for x. Second, To show that a function is one-to-one, you just assume that fa is equal to fb, simplify and show that a is equal to b. So fa is equal to fb implies a is equal to b. So that is another way to prove the prove that the function is one-to-one. Of course, you may use your calculator to make sure that it is one-to-one because it passes the horizontal line test. Okay, here question number 38. It's a little long problem. Fx is 1 over x minus 1, x is greater than 1 and a is 2. You are asked to show that fx is a one-to-one function. That is the first part of the question. Then the second part is you have to find the derivative of f inverse at x is equal to a, that is using the theorem that we discussed. Then the third part is find the f inverse x by differentiate and verify your answer by the direct method. And then there is one more part, that is you have to graph this f inverse x and fx on the same grid. Okay, so we are going to show that it is a one-to-one function. Fa is equal to fb implies, see, fx is 1 over x minus 1. So fa is 1 over a minus 1. 1 over a minus 1 is equal to 1 over b minus 1. That is a minus 1 is equal to b minus 1. Either cross multiply or find the reciprocals. And that now you add a 1 on each side, a is equal to b. So fa is equal to fb implies a is equal to b. Therefore, fx is 1 to 1. That is the first part of the question. Now, the second part is a little difficult. You have to find f inverse 2. So, fx is equal to a is 2. Fx is equal to 2 because a is equal to 2. 1 over x minus 1 is equal to 2. Cross multiply. 1 is equal to 2 times x minus 1. You multiply both sides by x minus 1. That is 1 is equal to 2x minus 2. You add a 2 on both sides. 3 is equal to 2x. So x is equal to 3 over 2. Therefore, if inverse a is equal to 3 over 2. So that's the first part. That is, you set fx is equal to a and a is 2. So fx is equal to 2. And that implies fx is 1 over x minus 1. That is 2. That implies 1 is equal to 2 times x minus 1. Solve for x. You get x is equal to 3 over 2. So if inverse a is equal to 3 over 2. That's the second part of the question. Now you are asked to find the derivative of f inverse at x is equal to a. This is the theorem that we have already discussed. And so you have to figure out f prime f inverse a, that is f prime 3 over 2. And you start with f inverse f prime x. Fx is 1 over x minus 1. So its derivative is negative 1 over x minus 1 the whole square, because the derivative of 1 over x is negative 1 over x square. You must memorize all the differentiation and integration formulas that you learned in calculus 1. So derivative of 1 over x is negative 1 over x square. Therefore, derivative of 1 over x, x minus 1 is negative 1 over x minus 1 the whole square. And now you need f inverse a. F inverse a is 3 over 2. So f prime 3 over 2. You need f prime 3 over 2. Substitute 3 over 2 here. That is negative 1 divided by 3 half minus 1 the whole square. And if you are not really good in arithmetic, you can use your calculator. Use a calculator. You are going to get a negative 4. I will show you that. Negative 1 negative 1 divided by 3 over 2 minus 1 the whole square. That is negative 4. So that number is negative 4. So since that number is negative 4, its reciprocal is negative 1 over 4. So 1 over negative 4, which is negative 1 over 4. So f inverse prime a is equal to negative 1 over 4. Now the C part. The C part, y is equal to x minus 1. You are we are trying to find the inverse of that function. Y is equal to x minus 1. X is equal to 1 over y is equal to 1 over x minus 1. So switch x and y. X is equal to 1 over y minus 1. And that implies x is equal to y minus 1 is x times y minus 1 is equal to 1 by multiplying both sides by y minus 1. X times y minus 1 is equal to 1. Now you distribute x. Xy minus x is equal to 1. Move x to the right side. So you get xy is equal to 1 plus x. Divide all the three terms by x. You get y is equal to 1 over x plus x over x, which is 1. So 1 over x plus 1. That implies f inverse x is equal to 1 over x plus 1. So that is the inverse. Now you differentiate this. When you differentiate this, derivative of 1 over x is negative 1 over x square. Derivative of 1 is 0. So negative 1 over x square. And replace x by a. What was a? A was 2. So negative 1 over 2 square. That is negative 1 4, which is the same as the answer that we got here. So you are asked to verify the answer. As I mentioned earlier, I know this problem is not very easy. You have to practice a lot. And now there is a D part, that is you have to graph this. Graphing, you use the calculator. So on the calculator, first graph is y is equal to 1 over x minus 1. You must be very careful. 1 divided by x minus 1 must be in parenthesis. And the second one is 1 over x plus 1, 1 over x plus 1. See the graphs. Again, x is greater than or equal to 1 half. So you have to impose a condition, x is greater than or equal to 1 half. So that means this part will not be there. So the graph looks like this. Okay, questions. I'm sorry. If you ask a question, I cannot answer because for if you have questions, please come to the online tutoring. I have already sent you an email regarding that. Now, question number 40. You are asked to find f inverse prime 2. A is 2. And first you have to find f inverse 2. Y inspection. There is no direct method available here. Y inspection x cubed, when x is equal to 0, fx is equal to 3 because it's equal to 2 because x cubed is 0 cubed plus 3 times sine 0 plus 2 cos 0, and so f0 is equal to 2. Another method to find that is you graph the function. So if you find that the inspection method is difficult, you graph the two functions. What are the two functions? That is x cubed plus 3 sine x cubed plus 3 sine x plus 2 cos x. So you have to close the parenthesis. 2 sin x plus 2 cos x. And when you draw the trigonometric functions, make sure that calculator is in radian mode. Yes. And the second function is 2 because you are setting them equal to each other. Function fx is equal to 2. So the second function must be 2. And now you draw the graph. And x is equal to 2. See, second trace intersect first line, first curve, second curve, guess. See, x is 0. So when x is 0, y is 2. That means if inverse 2 is equal to 0. Now you differentiate. F prime x is equal to derivative of x cubed is 3x squared plus 3 times cos x plus 2 times derivative of cos x is negative sin x. So 3x squared plus 3 cos x minus 2 sin x. Now substitute 0 here because f inverse 2 is 0. So that is equal to 3, and therefore f inverse prime 2 is equal to 1 over 3. That is it. The last question from that is fx is square root of x cubed plus 4x plus 4 is equal to 3. You may do the exact same technique here also. If you are not really good in inspection method, by inspection this is 1. But if you are not really good in inspection method, you can follow the same procedure here. For fx is equal to, clear everything, square root of x cubed plus 4x plus 4. That's the first function. Second function is 3. A is 3, so 3. And graph the two functions. Find the intersection point. Second trace intersect 1, 2, 3. You have to press 3 times. So x is 1, y is 3. So x is 1, y is 3. So that is it. So f of 1 is equal to 3. Therefore, f inverse 3 is equal to 1. Now you differentiate fx. Derivative of square root function is 1 over 2 times square root of x. You are applying the chain rule here. So 1 over 2 times square root of the whole expression x cubed plus 4x plus 4. And then you multiply that by the derivative of whatever is inside. So x cubed derivative is 3x squared plus 4x, derivative is 4, and then the other one is a 0. So that is f prime 4. Now f prime, f inverse 3, that is f prime 1. Substitute x is equal to 1 here. So 3 times 1 square plus 4 divided by 2 times square root of 1 cubed plus 4 times 1 plus 4. That is 7 over 6. Therefore, f inverse prime of 3 is 1 over f prime 1, which is reciprocal of 7 over 6. Answer is 6 over 7. Okay, that's all about that section. And now what you have to do is work out the homework assignment problems. And then if you have questions, you meet me online. My schedule is Monday through Thursday, 8 to 12 and 1 to 3. So I have 6 hours available. So I highly recommend you to meet me there. And okay, so we stop there.